Welcome. In this video, you will learn about how we can use a tree diagram to solve probability problems. Tree diagrams are wonderful tools to solve probability questions when events occur in succession. For example, consider a box containing 4 red and 3 white beads. One bead is removed from the box at random and then replaced, and another bead is then removed. The key word in this question is that you are selecting the bead at random. That means all the beads has fair or equal chances of being picked. The ball is then replaced. That means the total number of bead is unchanged. Therefore, when you draw the second bead, it will be the same probability as if you were drawing the first bead. This scenario is best illustrated by using the tree diagram. For simplicity, let's assume that R denotes the event that the red bead is picked. Since there are 4 red beads out of the total 7 beads, the probability of picking up red bead is therefore 4 out of 7. Similarly, let's assume that W represents the event that white bead is picked. There are 3 white beads in the box, therefore probability of picking up a white bead is 3 out of 7. This information can be illustrated by using tree diagram where each branch shows the possibility of getting either red or white bead as well as their probabilities. Assuming that red was picked in the first row and returned to the box, probability of picking up red again is 4 out of 7 since the bead is being replaced each time. And the probability of picking up a white bead is still 3 out of 7. Thus, this can be illustrated by another pair of branches in the diagram. Alternatively, it's entirely possible that you've drawn a white bead the first time. Since the bead is being replaced, the probability of drawing second bead will remain unchanged, and it is going to be illustrated by using another set of branches. On this occasion, we are interested in drawing 2 beads, therefore we have 2 layers of the tree, one for each bead. At the end of this experiment, we have 4 possible outcomes. It's possible that both times the red bead is chosen. You can choose the red beads the first time and white the second, or probably choose the white bead the first and red the second, or white the both times. These are all the possible list of events, so their probability adds up to 1. Events along the branches of the tree are independent events. Since the bead is replaced each time before you draw the second bead, the probability of drawing the second bead is unaffected by the event that you draw the first bead. And we can use the AND rule to work out the events along the probability tree, which means we multiply the probabilities along the branches of the tree. For example, probability of getting first red bead and second red bead is given by multiplying 4 over 7 with 4 over 7, which gives us 16 over 49. Similarly, getting the first bead red and second bead white is given by multiplying 4 over 7 with 3 over 7, which equals to 12 over 49. Getting white bead first and red bead second is therefore given by multiplying 3 over 7 with 4 over 7, which is equal to 12 over 49. And similarly, getting 2 white beads is given by multiplying 3 over 7 with 3 over 7, which then equals to 9 over 49. The events that beads shows the both red and white and red, and white are mutually exclusive events. For example, getting 2 red and 2 white beads cannot occur at the same time. You will either get 2 red or 2 white beads at a time at the end of the 2 trials. Therefore, in order to find the probability of getting 2 beads of the same color, we need to add up the probability of 2 reds with the probability of getting 2 whites, which gives us 24 over 49. There are 2 occasions when the colors of the bead is different. Therefore, the probability of getting 1 bead of each color is given by adding 12 over 49 with 12 over 49, which gives 24 over 49. Alternatively, note that since the event that you get the bead of the same color is mutually exclusive to the event that it is different color, i.e. not the same color, these 2 events add up to 1. And we have already found out that the probability of having the same color earlier. So therefore, in order to get the probability of different color, we could simply take away 25 over 49 from 1, which gives us the same answer of 24 over 49. There are 3 occasions when the outcomes have at least 1 red bead. However, out of the possible outcomes, only 1 occasions we don't have the red bead. That's when the both beads are white. Since the probability of all the outcomes add up to 1, we can simply subtract the probability of getting 2 whites from 1 to give the probability of at least 1 red. So this comes down to 40 over 49. Here's another example for you to try. Please pause the video and give it a go, then you can check your answer with me. Amy and Ben are going to take a driving test tomorrow. The probability that Amy will pass the test is 0.6. The probability that Ben will pass the test is 0.7. In part A, we gotta draw a tree diagram to show all the possible outcomes. Let's assume B is the event that Ben passed the test. From the question, we know that the probability of him passing the test is 0.7. B dash is then denotes the event that he doesn't pass the test. The probability of this happening is given by subtracting 0.7 from 1, as these two probabilities adds up to 1. Similarly, let A be the event that Amy passed the test. The probability of this happening is 0.6. A dash therefore is going to denote that Amy fails the test, which is given by subtracting 0.6 from 1, which gives us 0.4. Suppose Ben takes the first test, then he passes this test with the probability of 0.7. If Amy then takes the test, she can pass it with probability 0.6 or fail with the probability 0.4. Note how the probabilities in each pair of the branches in the tree adds up to 1. It should always be 1. And if you have a value greater than 1, then there has been a mistake in your calculation. This is a quick way to check to see if the tree diagram is correct. Also, initially, Ben could have failed the test with probability 0.3, and this could be followed up by Amy passing the test with 0.6 and failing the test with 0.4. Hence, there are a total of 4 scenarios that could happen at the end of these two tests. All these possible outcomes are the total sample space of our probability, and this completes our tree diagram. In part B, we need to find the probability that both will pass the test. In this case, we simply follow the branches of the tree, which shows both persons passing the test, and multiply their probabilities. This gives us 0.42. In part C, we need to find the probability that only Ben passed the test. We again follow the branches of the tree that shows whether Ben is passing the test, but Amy fails, and we multiply their probabilities together to give 0.28. Part D is asking to find the probability where only one person passed the test. This happens in two different ways. Either Ben passes and Amy fails, or Amy passes but Ben fails. So we multiply the probability across the branches of the trees and we add them together to give 0.46. In part E, we need to find that neither person passed the test. So again, we follow the branches of the tree where Ben and Amy do not pass the test, and we multiply their probabilities to give 0.12. If you find this video useful for you, please click like. If you think someone else can benefit from it, please share. And if you want to hear from me again, please do not forget to subscribe to my channel. Thanks for watching. Be sure to try the exercises to test your knowledge. I'll see you in the next part.